first of all, hello to everyone. Thank you for joining our webinar. Today's topic is Oops, Something Went Wrong, Quality Assurance at Implementing Green Roofs. And today we have three amazing speakers from different fields of the green roof sector with a lot of experience who will talk about their personal lessons learned experiences regarding the quality assurance and probably also things which might went wrong. So today, our first speaker is Jordi Serramia Ruiz from Spain. He's an architect and the chief technology officer and co-founder of the company Singulargreen. Then we have Tanja Herr. She's a general manager at Greenbox and also the president of GROF. This is the Croatian green roof organization. And then we have Dusty Gedge, who is EFB ambassador and also founder of Gentian. And he's from the United Kingdom. And then me from the EFB moderating the webinar for today. Okay, so before we go ahead, I would like to inform all the audience that this webinar will be recorded and later on published on YouTube. So we ask you friendly to turn off your camera and mute your microphone. So that we don't have any problems regarding this. And later on the link is available on YouTube, so you can rewatch it or share it with friends and colleagues. Then I would like to say a few words about the EFB, the European Federation of Green Roofs and Living Wall Associations. It was founded 1997, and we are a non-profit organization, and we are the umbrella organization for all green roof and wall associations in Europe. In total, we have 20 member countries and an extended network with Gentian, Althea, and IFLA, and as well so Green. And we are always looking for new cooperations and partners, so you're really welcome to join our network. Then I would like to say a few words to Fürs Grün. Fürs Grün was sponsoring a lot of webinars in 2025 and as well this webinar. So thank you very much for sponsoring us. Because of Fürs Grün, we can do this webinar free of charge, and it's a good method to learn more about green roofs and extending the network. So Fürs Grün is a system provider in the green sector with a wide range of products for green roof and gardens. And in addition to geotextiles and garden lighting, they offer solutions for pond construction and erosion control. They are based mainly in Europe, but they also produce their product, export their products worldwide. So you are also invited to check out their website and their program. So today's agenda, in total, we have 3 presentations. First, from Singulargreen, Jordi Serramia Ruiz will go ahead with his presentation regarding weeds versus landscape. After that, Tanja Herr will talk about her real-life practice experience from which she learned the most. And then we have a talk from our ambassador, Dusty Gedge, who has more than 30 years experience in assessing and evaluating green roofs. So he sees many green roofs and also knows what's going wrong. So you can be excited for his talk. After that, we have a Q&A session. So if you have any questions, please write them in the chat, and we can answer them in the end of all the presentations. Or yeah, when it's not too many questions, we also can answer them directly in the talk. So I know that Jordi, he would like to answer the questions directly in the talk. And then I will inform you about what's coming up and what are our next events. Okay, so for now, yeah, I would like to ask you, Jordi, to share your screen and start with your presentation.
Sorry, Jordi, we cannot hear you. I think you're muted.
I am not muted now. Okay. Thank you, Katharina, for the opportunity of talking here. First of all, if you have any questions, please raise your hands or directly you open your microphone and ask me, and I will answer during the speech. I'm going to talk about width and landscape. And this is my first slide. If you play the Street Fighter, you know what I'm talking about. We have landscape. Landscape is the design we are doing and how we figure the green roof would be. And the width, in Spanish, the word for width is malas hierbas. That is directly translated as bad herbs. So I like more the word in English because width is not necessarily a bad thing, but in Spanish it's a bad thing, the width. We could have a discussion about environment, what is good, what is bad, biodiversity, but the fact is when we design a green roof, we are expecting something, and in that something sometimes is not include something that comes from out to our green roof. So it is not necessarily bad, but always is something our clients does not like. I mean, it's maybe one of the main issues in the maintenance of a green roof. What says the FLL about width? The FLL says that we must keep the substrate with low nutrients, and that small widths does not need to be removed, and big widths we have to manually remove them. But FLL don't say so much about how we can control or how we can load the maintenance about that. So when we started making green roofs, we did this. This is a green roof with a low nutrient substrate. We planted with this design that has rosemary, festuca, tradescantia, sedum, lavender, no, and everything is beautiful at the beginning. The green roof starts to grow, the vegetation expands, and we get this. This is the ideal of our green roof with the design we did. But something is starting to happen. You can see here and here some weeds that are starting to grow. And if if you do control and if you do not do control, I don't know what happens to you in your green roofs, but what happened to us is, well, you think, maybe you think that when I'm talking about weeds, I'm talking about that, these beautiful small weeds that grow in between the sedum. Oh, what a small weed that is growing, let's remove it. No, I'm talking about that. I mean, this is the same green roof you see here from a different angle, and this is weeds. I mean, it eliminates completely the design of the green roof, and if you leave them there, at the end, almost every original plant of the roof could die to the newcomers. So does this to keep the design needs maintenance, and also sometimes it's dangerous because you can see here at the left a tree growing in a corner of the green roof, starting to grow, and you can see here the size of the weeds. I mean, it is not small weeds growing in the green roof, and we can easily remove them. No, that's not the problem. So this, I mean, I rule a company. Every maintenance is work and is business for us. But this is not the objective. The objective is to keep the green roof with low maintenance. And the ideal is that you install a green roof and you don't have to do nothing. I mean, you have to do nothing, and the green roof and the design keeps the way it should be. So that didn't happen in our early years of working, as you can see in these photos. But we have evolved and we have taken measures, and the measures I'm going to talk about, I think, are easy, and you all can take that kind of measures to keep the weeds under control. We designed that green roof system is called Rhizoma. I don't want to make I mean sponsoring of our system, because this is not the purpose of the speech. I think everything I'm going to talk about could be implemented in any green roof system you have. What do we do? I mean, the Rhizoma system has the usual layers of a green roof. I mean, the protection for the waterproofing, the drainage membrane, a fabric for filtering. In that case, rock wool substrate, and the most important thing, a weed control fabric double weed control fabric. So this thing that is usually used in landscape, I don't know. I mean, I don't know if you use that thing in your green roofs, but I have never seen using a weed control fabric in green roof. I don't know, maybe because we are worried about the green roof should be something natural, something with biodiversity, and some kind we think that any layer or artificial layer we introduce in the green roof is some kind of a betrayal of the ecology or something like that. I don't know. But I don't know why I don't see weed control fabrics in green roofs. And then a gravel cover that keeps everything dry and under control. Those are the layers, the drainage, the geotextile, the substrate, the weed control mesh, and the gravel. And this is how we installed we put the rock wool substrate over the drainage layer, as you can see, the rock wool already has the holes for the plants to be planted. Otherwise, it's really difficult to plant that rock wool because it's not a soft rock wool that comes in rolls. It's a hard rock wool that comes in panels, and that's important for something that I'm going to explain in another slide. This is the weed control mesh, and this is the irrigation system. The weed control mesh also helps to keep the moisture in the rock wool panel. So we solve two problems with only that one layer. That is, we don't have weeds, and we load the irrigation. I know you come from some countries that you don't need irrigation system, but in Spain it's mandatory. And to lower the consumption of water is a very important thing to take into account in green roof. So also the weed control fabric keeps the moisture in the substrate. We almost half the water need only with that layer, and then we cover everything with gravel. This is the roof planted. I think this should be the first or the second month for the planting, and I can show you. This is the roof with 1 year, and this is the roof with 4 years. And as you can see, this species is sedum, different kinds of sedum, and you can see how the sedum fully covers. I mean, you can't remove totally the weeds. There are some weeds that are growing, but the maintenance and the control only introducing the layer is a huge difference. I mean, it's really, I don't know what is your experience, but for us, something to keep a sedum carpet only with sedum is a really difficult thing. And with that sort of order of layers, we have achieved that. I mean, in 4 years, we can keep the sedum carpet as a sedum carpet with very low maintenance. This is different place of the green roof, and you can see here the lavender growing. Sometimes in the same place where the plant is planted, because it's the only place where the weeds can grow, the weeds grow. But in the rest of the green roof is really difficult for the weeds to establish. The gravel is a really important thing because it keeps it's the first barrier. Also gives the green roof the weight to keep put, and the wind doesn't take it out. And also protects the substrate from the sun and from the evaporation. The rock wool substrate is important because the moisture in the rock wool substrate does not distribute totally uniform. The moisture keeps in the low part of the substrate, so the upper part of the substrate is quite dry. I mean, maybe this is 10% moisture, 90% air, and this is 30-40% moisture, 60-70% air in the low part of the substrate. This is important because if you don't use a substrate that drains a lot, the moisture keeps in contact with the weed control layer, and also if the wheat is able to germinate in the rain on the weed control mesh, it would reach the substrate, that the substrate is humid and would grow anyway. So the weed control mesh itself does not do the thing. I mean, you need the weed control mesh and also the substrate in contact with the weed control mesh to be dry. That is very, very important. Otherwise, you won't achieve that purpose. And also, we like rock wool because we can keep control of the quantity of nutrients we have in the green roof. And this is the other important thing we do. I mean, the rock wool does not have any nutrient. We give all the nutrients via the irrigation system. And the irrigation system is one of the most important parts in our green roof systems because we are able to keep control of how much nutrients we give and how much the plants we put, how much grow. Let me show you. Let me go out of the presentation. This is the remote control we use. And this is the green roof I'm talking about. You can see here all the sectors of that green roof. It has 5 sectors plus a vertical garden, the sector 6. And we have all that sectors with only irrigation of water, and all that sectors that give the irrigation with fertilizer. So from here, we can remote control how much fertilizer we give to the green roof. If we are seeing that the green roof grows a lot, or maybe has some problem with any nutrient here in our place, mostly we have lack of iron in the green roof and the vertical gardens, we can rise the levels of fertilizer remotely without being there. That kind of control saves a lot of maintenance for the green roof in the long term. Also, is that kind of systems are very, very light. I mean, 67 kilos per square meter is quite different than 170 that is a regular roof. For that kind of plants, I mean, lavender, rosemary, and that. And this is the final image of the roof. If you have any question, please.
Thank you, Jordi, for this great presentation. So in our chat, there are no questions so far. Yeah, then I would suggest to, if later on questions will arrive, maybe you can spare them for later. And then we could go on with the presentation from Tanja.
Here I am.
So good afternoon, everybody, and thank you for sharing your valuable free time to stay with us. I'll start immediately. I have lots of pictures rather than words, and I hope it will be funny and educational. Let me just share the screen. Oops. Yep. Do you see it? Kathy, is it okay?
Yeah, great.
Okay. So just to remind you where you are and who are you with. So this is me. I am the general manager, which sounds very posh, but actually I'm just one-man band in the firm, and somebody has to do it. Recently, we also formed a National Association for Green Roofs and Facades. We name it GROF in our language, actually means the count. But anyway, it's a young organization, and there are 2 younger colleagues together with me in that. We haven't done much yet, but we have big plans. So let's go to see what can we, or where can we go, in which direction when we investigate what went wrong on green roof. By being an architect myself, being over a quarter of a century in the waterproofing and installation business as a technical advisor, my first concern is the roof. The roof is actually part of the building, and green roof is just one sort of ballast on top of it. So when something goes wrong, there's usually a leakage. It could be construction or architectural detail guilty for it, or, well, landscape design is something else. So I divided my case studies into 2 categories. One, or the first ones, are the ones where the leakage occurred because of poor details or poor installation or similar, and few where landscape design or green roof system was actually wrongly chosen. So both can go wrong in the design phase, but mostly they go wrong in the implementation phase. I'm talking about Croatia, where we have no regulations, and although there is now substantial practice in it, there is an Eldorado for everybody that hears soil, earth, plants. Then they grab what they can grab the cheapest possible, and sometimes they make very expensive mistakes. So let's go through the few case studies. First one is a private house in Zagreb. This is capital of Croatia. A flat roof with a slight inclination of 8%. 3 sides are bordered with the attica, as we call it, so it's the little absent, and there is a gutter at the long edge where we were supposed first to think of something that will keep the substrate or the green roof system in place, not to slide down into the gutter. So on one site meeting, I came across the idea to form a little gabion or little basket made of perforated steel, which was equipped with, if you can see it here, with a waterproofing membrane stuck to it at the bottom on a very, very gentle way, so it would not harm the waterproofing, and it was basically fixed with a hot air welding onto the waterproofing. So no drilling, no invasive attachment to the, you can see it's all along the membrane. It was just welded, and it was executed by the applicator of the waterproofing membrane. Unfortunately, it was a long time ago. I don't have the exact pictures of this site, which actually later on showed as a problem. So very, very carefully, we placed the drainage within this basket where the gravel will come later on. So we placed everything before the planting. Oops, there comes another company. They were just about to install some solar panels. So we said, okay, no problem. You just walk on those EPS drainage elements and use it as a base for your poured in situ concrete, and we'll all be happy. They were happy, we were happy. But the leakage came. The leakage occurred, and we actually thought, who is guilty of it. The leakage actually was present here at the very edge. And why it happened? It was because the waterproofing applicator installer made a very poor, clumsy detail, which was okay while there was no ballast on top of it. Once we put gravel on it, we created a tiny space which caused capillarity to drag the water upwards, and when the water reached the place where it could go again down due to gravity, it actually leaked onto the facade. The installer was not happy when we claimed that his mistake, but he did it. He never paid us to wait for him to remove the part of the roof, thinking that we were guilty of it. But you can see the roof is actually now very successful, and I can assure you there is no maintenance there whatsoever. So the next case study is the reception of the very prestigious hotel in the northern Croatia, where I haven't seen the messiest building site as it was this one. So there were 3 new buildings, and this is the old building. So they connected the old and new buildings with a green roof, or the roof under which there was a reception area and a congress hall, so very posh area. One needed to be very careful. But due to these adjacent old buildings, the green roof substrate for the real English lawn could not be thicker than 10 centimeters, the most. So we used something rather similar to what Jordi explained previously, just another system. So there were dripping pipes sewn into the geotextiles, 2-3 layers of geotextiles, and this is actually the base which enables this beautiful grass to survive on such a thin roof system. The problem actually happened when we put the grass on it. You probably all know that you need to water it intensively for the first couple of days or even more, and this is when the leakage happened. It leaked around the water outlets. And why it happened? It was actually due to the wrong tool that the applicator of waterproofing installed by connecting the water outlets and the waterproofing. So he did a very dense zigzag seams, which actually created capillarities, which later on, when the waterproofing was inspected by the water sitting on the roof for 24 or 48 hours a day, right? And you know how it is done. It is done that you put a patch of this waterproofing on top of your water outlet, and you actually make a welded seam. Later on, when this water needs to be let out in order to put another ballast on it, you just cut out the round circular opening, and the water runs through the water outlet. Unluckily, because of these capillaries, the water, when you watered the greenery on the roof, actually had the access, and it was again sucked within those capillaries, and it leaked every few seconds a drop, and it was a nightmare. So we solved this nightmare, and soon enough there was another one. There was those skylights which were covered by the waterproofing membrane until the glazing came. The glazing people came onto the site, they cut off the membrane, the rain came, they ran off the roof, and the manager of the hotel called me. I was 80 kilometers far away from this building, and she said, "Tanja, it's pouring, it's horrible, what have you done again?" So I drove there like crazy, because nobody went on the roof to see that these openings 1.5 meter by 1.5 meter were absolutely opened. From the downstairs, they probably thought it was glazing so clean, or I don't know what. But anyway, everything is well, what ends well. So this roof was, in terms of leakage, sorted out, and we were happily gone. There was another thing which I will talk about later, again with this glazing, but this is actually another problem. So let's go to the next case study. Again, a hotel, and a very beautiful design. The architect was very proud, and there was a company that tailor-made those skylights, and there comes the problem. We've got beautiful protection of the waterproofing membrane executed by XPS, which is a very welcome application. But as you can see here, all these bits and pieces, it was the pressure of time, non-very skilled workers, and they were really having hard time to make a nice, round, tight surrounding of these skylights. So what they did, which was not seen before the landscape company came on top of it, they covered it with geotextile, and they made cuts exactly here on the very top of the XPS. These cuts were smeared by some paste or something, which was later on discovered when all this beautiful roof needed to be taken down, and everything needed to be repaired. So messy building site, rush, non-skilled workers, and another clumsy detail: people who gave the coverings for the chamber inspection chambers. They put the wrong ones with the very big openings, and you can see here this is Mediterranean forest of the pine trees. So in the course of 1.5 year time or 2 years time, the needles actually went into this water outlets underneath, and they clogged them. So one very heavy rain brought up the level of water up to those sensitive area where the installers actually cut the membrane and tried to smear it with some non-good solution. I described what I just spoke about. This is actually something for me as a reminder to say there is a mosaic of the guild on this project. The architect who made those rounded, they could have been squared. The squared skylights are much, much easier to insulate on a better way. Then there was also the investor who made up his mind until the very late date, but the date of the opening of the hotel was fixed. So everybody was in a rush, in a hurry, and some workers were taking from God knows where. So when it came to the actual guild, of course, the hands of the guy who was having the knife in his hands, he is directly guilty, but all the others are also responsible for it. Let's go to a very funny, very beautiful, but also a funny case study where this cantinetta, it actually serves the students of agriculture and forestry faculty in Zagreb. Nicely done. But there was a plan to have on these posts, they were supposed to have some containers for the guest professors. This was never built, but for those containers, if you can see the little bump here, they provided the pipes for the sewage and for the water. So the only solution which we tried to implement there at the site, this was my colleague from the XPS company, and we came and said, okay, can you at least split the thickness of XPS in 2 × 5 or 6 centimeters rather than having all XPS underneath of the membrane. Thus, we actually will help for the further maintenance, that the green roof will be maintained safely, but the waterproofing would be also protected here. Little did we know how this would end at the end of the day. So all these layers were placed here, some 30 centimeters of substrate, and everything looked perfectly well. Until one day, because they did not make their minds, the dean of the agriculture and the dean of the forestry faculty, they were not very keen on giving money for the plants itself. So the nature took its way. This is actually almost a meter high grass. A very skillful majordome of the faculty came with this device on the roof. This was picture taken from the internet because I did not see it. I just got the furious phone call from the architect saying, how much substrate do we have on this roof? So, well, roughly 30 centimeters. Do you know what this idiot did? He hit those pipes, which were Okay, they were not filled with water, but he actually cut the membrane. And the roof, which you can see, this is the rand of the roof. It melts with nature very beautifully. Those containers were not built there, but the maintenance actually is, yeah, not the greatest ever. But this would happen there is to come with such devices on the roof. It's just, it should be forbidden. But once the architects and gardeners are gone, people who maintain the building, they do not necessarily know what's underneath. So these are the examples where the building or architectural details are to blame for something that went wrong. What about the green roof systems? There's a small design which was first time implemented in Croatia with this mineral wall, similar to what Jordi explained. We did not know how to fix it on such metal roof, also very much inclined. So we made dimple membrane with some laces like shoelaces, which will later serve to fix the wall on it. We glued this dimple membrane on the metal deck, and on the site we actually were inventing the details. You can see the knitting needle here that we use to fix, because it's a very windy area, to fix the mineral wool on top of it. Okay, once done, we put the netting on top of it, planted the plants, and well, all looked well for the time being. We hope that the plants will actually grow over this visible part here. Unfortunately, it did not happen like this, because the owners did not take care of it. They did not water it. And yeah, the wind and the degradation of coconut mesh was present already on this sloped area, but on the very top, it was the worst. So one storm came and it all went, it was all almost gone. So how to maintain it? First, we installed some wooden ladders, and to serve as the base, where we later put the netting, which will prevent the wind erosion, but also the soil erosion. We also instructed the investors that not only those carrots and paprikas and whatever they had here in this roof garden needs to be watered, but these modest plants, the sedums, are also to be watered when needed, because we live in a continental climate where the temperature that can rise nowadays up to 40 Celsius degrees in the summer. So now it looks rather neat, and it's also secured. So let's go to another one, where this is the Museum of Miners in North Croatia, and the architect wanted to have some wild grasses on the roof, so the visitors would have the impression they entered the mining hall. The guy who implemented those plants wanted to sell something more expensive, so he brought some fancy plants which could not survive. You can see some Sempervivum here. It did not survive because the substrate was too grob, and it was actually barely just a crushed bricks on very, very big granulation. You can see Sempervivum that I plucked out. It didn't develop the roots. It actually barely survived. So I analyzed the substrate. We removed what it was possible to be removed, put the new one enriched with another component, took the sedum carpet. This was silly me without any protection on the roof some 8 years ago. Today I wouldn't have done it. And this was the roof straight after installment. Half a year later, the roof survived. Here are some weeds that actually inhabited it, but today we will not call it weeds. We will say the biodiversity took place on this roof. And so far, so good. Let's go to another hotel. This is actually the same hotel I mentioned previously. Now there is another problem where they told us that the grass is gone yellow. it burned. How it burned? It looked all so nice. We also have a nice and clever watering system. Everything looked perfectly well. But the dry patches were here because the glazing came much, much later after the opening of the hotel and after we finished the green roof, and the people took the glazing, which is, if you remember, 1.5 by 1.5 meter big. They put it on grass and worked the whole day long on these metalworks. And then, of course, the grass, you can see the precise shape of the glass was burned under the hot Croatian sun. So this was actually very nice for the opening. We repaired those green patches, and cheers to the hotel. And it seems like I've finished, although I thought it would last longer. So thank you for your attention. Are there any questions?
Thank you, Tanja. That was a great presentation and interesting examples. Yeah, we do have some questions in the chat.
I hope it's not from Dusty. It is. He wants to say something.
So did you have, then the first question is, did you have to remove the roll system when it happened?
If we needed to remove what?
The whole system when it happened.
Basically on the hotel with those rounded skylights, they removed everything because they were, of course, quarreling who is to blame for the leakage. And the leakage showed only when they removed completely the green roof, which was a big issue. But luckily, when they removed it, you could have seen on the vertical part of waterproofing around those skylights that the clean part was exactly to the upper level of XPS, and the slightly dirtier part was where the green roof is, and the cuts were exactly on the rim of that circle. This is how we actually prove that the gardeners could have not damaged the membrane. On the others, there was partial removal, so various things, but it's always at the expense of the gardener, because the waterproofing people, they come, they make their inspection with water, the water stays there for a couple of days, and they say, oh, there is no leakage, we're gone. Everybody signs the paper that the roof is functional, and then the gardeners come, and then they are actually in a very bad position if anything happens. But as you could have seen on this family house, where the waterproofing guys did actually not only poor data, but the wrong detail. So the person to be blamed is always found, and it's rarely the gardener, from my experience. It's always someone before him, and the details were hidden or not seen at the first sight. Please do let Dusty talk, because he has raised.
Just following up, because I haven't put this in my talk, but you're quite right, Tanja. In my experience of 30 years, every roof that's leaked, they've blamed the green roof, but it was always other workers with scaffold poles, or fixing in, like you said, the solar panels, or the waterproofing wasn't installed properly. But the green roof is always blamed, and I've got several examples where the green roof has been taken off, and then they find out the leak wasn't where the green roof was. So there's always an assumption. So I just want to celebrate what you said, because actually nearly 99% of the time, unless you go on the roof with a rotavator, which I just thought was amazing.
Actually, it did happen. It did happen. But just to add to that example is that I was called there. This was all happening in 2016, 17. I was called there just last summer because they had leakage in the kitchen area. And why is that? They had this vents made out of steel, which protruded the waterproofing and everything. They went out of the green roof. And there was no leakage until the kitchen wasn't working. For some financial reason, the kitchen was still for quite a substantial time. And then when the kitchen started working, there was lots of vapor going out through those vents, and the vents were not thermally insulated, thus making the condensation happen somewhere on the outer side of those vents, going actually underneath of waterproofing. So there was no hole to be blamed, but the constant condensation that happened due to poor or no thermally insulated elements which were actually standing in the cold air. But, you know, when you come to such cases, people do not believe. They just want their fix to see the hole, or that somebody has cut it and somebody has done some damage. But sometimes it's just, well, this is actually the architectural wrong detail, I'd say.
Christine's got a hand up.
Yeah, thank you. And it actually follows on from Dusty's query, the all caps about the motor cultivator on the green roof. So yeah, that's absolutely shocking. Sounds like that was a frustrating project. And I was just curious what happened after that. Like, did you have to take the whole system off? It was obviously super damaged.
No. This is actually it just happened when the motor cultivator hit the first pipe. The guy stopped, so no bigger damage was done. But nowadays nobody actually has seen it. We've just heard about it. There is no pictures of it, just this one thing that was a warning sign, and he stopped. But the problem is that the roof is easily accessible with such heavy machinery. And, you know, the guy is not to be blamed. There was no instructions. There was nobody there. And he just wanted to get rid of the weed. And this is how he did it. But no, the roof is around 1,600 square meters big. So no, it was not completely replaced. It was restored then and there where it happened.
May I ask a follow-up? Because I remember the vegetation was not to your liking either. So how did you restore that then?
Well, I wasn't the gardener there. I wasn't the landscape company there. The building company actually took them all out. This was another story, because they treated this as weed. And I said, well, it got semen on it, so please cut it carefully, put it in some bag, and then later on pull them all out. What they did, they pulled them all out immediately, so they actually reseeded the whole roof again with those weeds. But anyway, yeah, these things happen when there is nobody really in charge of maintenance or somebody that knows what to do.
Okay, thank you. Then I think all questions are answered for now. Thank you, Tatiana, for your presentation and your response to the questions. I have a few questions for Jordi here. Would you like to answer them now or later?
We can do it now.
Okay, so the first one is to plant those systems, the weed membrane would have be pierced so the plugs can reach the moisture in the rock wool. Yeah.
Okay, the plants...
And would there be an opportunity to use both seeds, mixed and plugs?
That I didn't understand the last thing. Could you repeat it?
If it would be possible to use both systems, the mixed one and the plugs.
Both system, the mixed one?
And the plugged system.
I understand the words, but I don't fully understand what he or she is meaning.
Okay.
Okay.
Well, then maybe we jump to the next question.
No. Let me answer the first, because the question is split in two. He asked that how the plants reach the moisture. No.
Yeah.
Yeah. So the plants are planted in the substrate, in the rock-wool substrate. So when for planting, we make a cut in the mesh in X, and we plant the plant in the rock-wool substrate. So the plant is planted directly in the rock-wool substrate. Only where the plant is where the weed can grow, because in the rest of the surface of the green roof, there is only the weed control mesh. This is the answer of the first part of the question, but I don't understand the second.
Okay, then we stick to the first one. And there's another question from the Madrid City Council. I have a question for Jordi. Leaving aside the weed problem, what problems might arise in the medium or long term due to poorly executed project? I'm referring to the design, not to the construction. Does the rate of green roofs increase over time? If I say some comments that the rate increases, and of course it's something to consider. Do you know anything about this? And have you had any cracks in the roof structure due to this issue?
Okay, he or she is asking that if the weight of the roof increases with time.
Yeah.
Always. Yeah. I mean, always the weight of the roof increases with time, because not in any system, because dust and the plants and the pruning of the plants, of the leaves, everything falls in the substrate. So always the weight of the roof is increasing, but I mean, it is not an increase that should be taken into, is not as big as to be taken into account in the structural calculation, because you have the dead load, the main load of the and then you have a maintenance load, and you have how it's say in English, the maintenance load and the mobile load. So if you have the dead load of the roof, and you take into account the possible loads and the snow load and the rain load and the water load and everything, it's very rare you have all the loads at the same time in the roof. So you have enough, let's say, enough margin of safety always.
Yeah, you're talking about the live load, Jordi. I think you're talking about the live load, yeah.
Live load, yeah.
Okay, then I hope with that the question is answered. And regarding the time, I would like to ask you, Dusty, to start with your presentation.
Okay, I'll just...
Thank you, Jordi, for answering the questions.
Sorry, I'm just getting my camera on. I'm going to share. Give me a moment. Here we go, play. All right. Can you see that okay, everybody? Somebody shout out yes. Yeah. Can you see that?
Yes. Great.
So I'm just going to tell you a little bit about me, because it's going to put the context of what I'm going to talk about in. That roof was 20 years ago. It's a very simple cedar blanket and was never irrigated and is very exposed to the wind. I was the president of the Federation. I like to put this picture in because years ago I was a punk. I'm one of the UK's leading experts, independent of any company. I think this is very, very important. And I've designed, specified and inspected thousands of green roofs across the United Kingdom. And I've actually visited thousands of green roofs all over the world. And nearly most of the policy and guidance written in the United Kingdom has been written by myself, my colleague Gary Grant, for people in the UK. But this is very, very relevant when I talk about where things go wrong, because actually we're talking about policy and delivering what cities and the English government wants. And last year I inspected all the City of Westminster's own green roofs, which is very, very interesting. So I went from being an activist to an expert. I wrote all these reports, I wrote all these guidance, but more importantly is this biodiversity net gain metric, which is a legal requirement in England. And essentially I wrote that metric, and it's in line with the way that they often do green roofs in Switzerland. And it's important to say this because of the context about what goes wrong. And I've just updated the metric for the next iteration, which I'm not sure when's been published. So let's take the title, During Installation. Well, I think just quickly to back up what Tanja said, generally green roofs don't cause a problem. It's generally waterproofing, bad structural design, and the green roof gets blamed because it's seen as new and modern, and therefore it must have caused the problem. And I noticed there's some people from Recover Roofs on this talk who are from Boston, and I know quite a few Boston contractors in the United States of America, and most of the really good green roofing companies in the UK now do a leak test before they install. But I'm not going to cover that. But most of the problems that I encounter and clients encounter or local authorities encounter is actually before anybody's even got on the roof. It's the design and specification. And most of that is done from an aesthetic or a structural perspective. And it's not from a functional perspective. And also, and I really want to celebrate Tanja here because she did say something in one of her case studies. In the construction industry, everybody goes for cheap. And there's a lot of cheap out there, and that can lead to problems later on. So I'm going to very, very specifically talk to you about what is the driver now in the UK, which is not sedum extensive green roofs, but biodiverse extensive green roofs according to the metric. And this is basically what I'm going to tell you, because the design and specification for most architects and clients is, and structural engineers, is keep it as light as possible and make it look as good as possible, but with as little maintenance as possible. And the way it should be approached is actually function and performance first, not weight and aesthetics. They come later. But that is generally how most green roofs are specified and designed, unless you've got strong policy and guidance. Now, this is a classic example. This is a system. It remains nameless. This system is 44 kgs per metre squared. And this is on a balcony, which has actually got planters on as well. So this system was specified because it was light, and it was specified with irrigation. And this system at that thin needs virtually constant irrigation daily to stay alive. And that means it's not an extensive green roof if you follow the definition. Because if something's being irrigated daily, it's an intensive green roof. And I just want to highlight that because that's the original definitions. That if intensive green roof is high maintenance, extensive is low maintenance. Now, you've got a nice publicity shot, but nearly every time I've encountered this system, which is so thin, it's virtually dead. And that is because weight and a publicity document was what drove the person to buy this product. And this is a very similar system. And as I said, in the manual, it says should be irrigated in periods of hot weather. Now, I don't want to bore people, but I'm sure people who know buildings is in facilities management, i.e. the people who manage buildings. If in the manual it says should doesn't equal must. And I spent years talking to facilities managers who say, if it says must, we will do it. If it says should, we probably won't. And so that's a very key point, that is. And I would suggest to people, if you want to make a green roof that's going to last, you focus on function and performance. And performance values are key, and they're going to be key, certainly in the European context with the new guidance that a few of us have been involved with writing for the Commission. We want good water holding capacity, survivability of plants. Now in London and England and Switzerland, it's biodiversity. So there's a lot of malherbs, if you don't mind me saying, Jordi, a lot of things that maybe people don't like, but that is the way that the BNG is written. But it's got to have low but healthy maintenance. And what people do when they hear low, it often means no. And one of the problems I have is I specify a lot of green roofs to meet regulations. And again, this is all going to be nameless. The system suppliers then play on the insecurities of the architects in this case and change the specification. And this is a green roof that had 80% wildflower turf put on it. It was not designed like this. And I was asked by both the local authority and the client to sign this roof off. I refused because it didn't meet the specification that went through planning. And this happens a lot. And I think, again, it was aesthetics rather than actually performance that was the architect's insecurity. And by the way, this system increased the cost, I know, by about 50%. So it's a cost issue as well. Now, this is very controversial. This is a really lovely, fantastic green roof I visited in Italy. My friend Maurizio Crassa, who's our Italian rep, and he has a company out there. Now, one of the things here is this, I visited this roof during when there was an irrigation ban in northern Italy because of lack of water. It was actually May, June. And the grasses died and the client wasn't very, very happy. Now, one of the things in our guidance and our metrics is no grass. Now, people get very upset about this, and ecologists will go, oh, if it's not got grass in it, it's not a proper ecosystem. One of the problems with grass on a green roof is it needs a lot of irrigation to not go brown. And if you actually go out to some of the natural landscapes in the environment, this is a chalk grassland. Now, there's calcareous grasslands all over Europe, north, south, east, west. And when you have really good chalk grassland, it only has about 10% grass in it. And it's mainly wildflower dominant. And I'm just highlighting this because this is a cockleshell beach in East Kent, where I'm from. And this is what a green roof should look like in the summertime. And you can see on the right-hand picture, there's a lot of sedums there. There's 4 species of sedums on this, but there's no grass because the grass can't survive in the cockleshell. And what I would say to people is, when I talk to designers, we have this perception of what is natural, and that's often associated with agricultural land, which has grass. So don't restore, replicate. And I've got a whole... What's the upset? On my YouTube channel, if you're interested. And I did say that I would speak a little bit about biosolar in terms of what goes wrong, because biosolar, there are a lot of problems with biosolar if you specify the wrong solar system. And we get a lot of this all over Europe, actually. This is a solar mounting system which is designed for a non-green roof. And you get poor height above the substrate. And what happens is water runs off the solar panel, goes under the panel, and woody stemmed plants, which you shouldn't have on an extensive green roof, can take hold. And they can actually block out the sunlight and stop the panel functioning. And if you generally, in most installations, if one panel goes, all the panels go. And I'm now going to show you a picture of a really bad biosolar green roof. Oh, no, not that one, this one. This roof never produced any energy because they've forced the green roof around it, and the solar panels are the wrong height. And going back, some people from Recover might know who this is. This is Peter. I inspected these green roofs in Westminster, and these have got the wrong mounting systems on it. And already the vegetation is starting to cover the solar panels. So one of the things that goes wrong is you get oh, there's a solar mounting system, we'll use that. But was it designed to actually work with a green roof? And the other issue is, with the last picture, I'll just remind you, is the solar engineer wants to maximize the amount of solar panels. Well, you can't do that on a good biosolar green roof. You have to have at least 30%, and I would prefer 40%, without panels on it. And if you get that, then you get good spacing between the panels and less woody stem plants. And I'm just highlighting this because there are a lot of very good systems. There's 3 I know in Europe. They're actually designed specifically for green roofs, and they're called integrated solar panel green roofs. And I don't need to highlight the companies, but that's the way to go forward if you want to design a really good biosolar green roof. And there's, you can see, a very good biosolar roof that I'm going to do a video of shortly, just showing the mounting system. And the mounting system is integrated into the green roof system, which is what's important. And when you do that, you get good energy production and you get good biodiversity, which is what I'm specifically interested in. So think function, not weight and aesthetics first. Weight and aesthetics come later, not first. Keep grass out. Ensure roof designed, not just an off-the-shelf product, because green roofs are an ecological landscape. They're not a building product. And inspect what's going on, because I have to try now to inspect whatever the contractor is going to install, and does it marry to what was specified? And then I inspect the installation, and then I sign it off. Thanks very much. And as I said, there's lots of YouTube videos about biodiversity and green roofs and habitats across the EU and now actually across the world. I'll stop sharing. Thank you very much. Where's the stop sharing button? Oh, sorry. Trying to find it. Share.
Thank you, Dusty. That was a great presentation. I'm looking to the chat if they arise any questions.
Nobody ever asked me any questions. I think I'm going to upset them.
Dusty, great presentation.
Maybe
are there examples of drought-tolerant grasses that will work?
Well, who's asking that? If you don't mind, I can't see you.
I was told that this is Mark Winter with Recover Green Roofs. Thank you for all the plugs.
So.
Yep.
Yeah. No, well, so in different contexts, certainly down in the Mediterranean, there are dry grasses there, and down in the south of the USA, and probably even maybe up on the East Coast, that would be appropriate. But in a very temperate climate and a maritime climate like the UK, grasses will take over the green roof. And I have to do this, if I may, and I'll come back, is when I first got involved 27 years ago going to Germany. In Germany, the rule was 1 year sedum, 2 years sedum some grass, 3 years grass and sedums, 4 years grass, if you don't maintain it. So when you're in a climate like ours, grass can take over. But once April, May comes and the heat comes in, the grass goes brown unless you irrigate it. So I know down in some parts of Texas and down in California, they've got some drought-tolerant grasses, which are appropriate. But it's certainly in the northwest of Europe, and I think even going down into France, and certainly I know in Switzerland, when you get things like ryegrass, which can easily colonize a roof, then you're going to get grass infestation, and if you don't irrigate it, it's going to be brown. I hope that sort of answers the question.
Yes, thank you.
Sorry, Mark.
If I may just make a point, this is not directly a question to you, Dusty, but since you went for this biosolar roofs, there's also an issue of fire on such roofs. So by having grasses which went brown, meaning dry, and some solar panels and electricity on it, we also enter the danger of having fire on such roofs. I would not encourage high grasses, but as you said, this is succession of the plants. We have the 13-year-old roof in Croatia where we planted, I think, five sedum sorts, 7 plants per square meter, which is very, very little. And after 13 years, my colleagues numbered some 40 different varieties of plants which inhabit this roof. So one can say it's unsuccessful. Yes, it's not extensive root with sedums, but it's actually very successful biodiversity example, which actually stays there with no watering. It's a large area of almost 3,000 square meters. What they do, they also maintain it twice a year, or even in the summer, they cut those grasses, which we said, okay, if you do it not so often, you might actually benefit from the seeds that will be born there, and the roof will be more green than it is now. But anyway, the next webinar might be on the fire protection of the biosolar roofs and what the grasses actually do, or plants, to those roofs. I'm absolutely for your suggestion that minimum 40, if not 50%. If it's green roof with solar panels, 50-50 would be fair, wouldn't it? And then the solar panels or photovoltaic panels could also benefit from this cooler area around them and to be more efficient, as I read in some studies.
Yeah, that's true, Tanja, but I don't necessarily agree with you about the grass and fire in terms of extensive biosolar green roofs. I'm not so, but we won't have an argument about it. But this picture on the Q&A is a beautiful biodiverse green roof. Now, one of the things, Tanja, this is not criticising you. One of the problems is when we say green roof, when I set up livingroofs.org, it was invented by an American, that term, is because green roofs don't have to be green all the time. And we're fixated with the colour green. And I just wanted to highlight that. Now, Mark, you've got your hand up twice now. So do you want to ask a question, Mark?
Yeah, thank you, Dusty. And first of all, thank you all for putting this together. In America, we look towards Europe as a model. You guys are a couple decades ahead of us. So we want to see what works for you and what we should be doing. And you know, we want these green roofs to be a part of the solution, not a part of the problem. And irrigation, you know, is our most precious resource, and green roofs need water. You know, they're not deserts up on a roof. And I'm trying to develop a more sustainable green roof system with less inputs, and looking to the European German models. And we've been pushing or encouraging or recommending granular drainage systems, and even potentially holding a little bit of water at the bottom of the granular drainage system as, you know, a quasi blue roof as a water reservoir for those extended droughts. In my mind, you know, you're harnessing that rainwater and when you need it, instead of tapping the city water when it's, you know, there's a scarcity of it. So does Europe have examples of this being an effective way of making a drought tolerant system that we could follow?
Well, if I may, on that, and I actually missed talking about it, and I just want to celebrate Croatia because they're translating the Italian codes of practice. To answer that question, what in Italy, they are very, very sophisticated in terms of how they create their substrates and their irrigation processes. And what they talk a lot about is the performance in terms of plant available water. And there's a very, very special curve that they follow. And I find this very, very interesting. And we're probably going to have to use that in the UK at some point as climate change happens. So plant available water is, if you know somebody in Boston who can speak Italian, you can get the Italian norm, but they haven't translated it yet into English. But I would recommend that.
La note qui parlait, franchement, il parlait.
Hello, could you mute yourself? But I know, if I may, Mark, you know Pete Ellis. He's also talking about this with the Italians as well, because I know you know Pete Ellis. So I think that's the way, is irrigate as little as possible. So they have a very sophisticated plant available curve, which tells the irrigation system to go on when that curve is at its critical point. And it's very sophisticated, so they use a lot less water than is actually used in other areas because of this plant available water curve. But I know I've spoken to Tanja about this for Croatia, and I think, Tanja, you said this morning, didn't you? You're translating the Italian norm, aren't you?
Yeah.
Yeah. I think Jordi's got a question.
Okay, yeah, Jordi, you want to answer? I saw you raised your hand.
Yeah, I wanted to talk about water regarding the last question, because we have a lot of experience in water storage in the low part of the green roof. And the issue in Spain is that if you have in summer evapotranspiration of 4, 5, 6 liters per square meter, if you are able to store, let's store maybe 20 liters per square meter, 20 liters per square meter is 4 or 5 days of irrigation to keep the green roof green in full summer. So there is for us in the water storage is for rainy climates. I mean, it's for UK, it's for Croatia, it's for Germany. But in Spain, the water storage, or I don't know the person who was asking, I suppose he's living in an arid or in a hot climate. For hot climates, despite you would think, the water storage has no sense, because any water storage you can do, it lasts only a few days. So to have an irrigation system is mandatory. And once you have an irrigation system, the point is to optimize the irrigation system, not to store water anywhere.
Okay.
Not too sure about that, but
Thank
Jitka's
you.
had a hand up for a long time. Jitka, you there? Where are you? Jitka Dostalova. Can I ask the question?
Yes. I have had a question to the green roof, which was with a slope, pitched green roof.
Yep.
It was on a metallic underlayer, and it seems me not to be a very good solution, because the metal can have a corrosion, and it can destroy it. The water and everything what's above, it can destroy the metal with the time. I think it's not.
Tanja, do you want to take that
No,
one?
I answered in chat. So this was galvanized and plasticized steel metal. It's a small roof. So, and the system that was built upon this roof was protected, first of all, with this plastic sheet of drainage membrane with a geotextile integrated on it. And then there's this mineral wool layer and the substrate. So basically, in Croatia, as we learned from the meteorology, the rain that comes, this average quantity of water that comes onto such thin roof of 6 to 8 centimeters, only half of it comes in the lower layers. So the water actually goes, when it goes through the planting system, through the substrate, it comes, and through the mineral wool, it comes to the plastic sheet, which is continuous. So basically there is no way that any water can get to the metal decking. But of course, on the larger metal deckings, this would be an issue where they have overlaps of the metal sheets, where they are cut to size, etc. This is where they are not protected. But this was just one long piece. This is the advantage of this small roof, rather big slope. And as you saw on the flat area of that little roof, this was all very dry because it's windy there. So anyways, so whatever water comes onto this green roof, only half of it eventually reach the lowest layer, and the lowest layer sits exactly on the metal decking. So,
and what about the condensation?
Okay, I think
Between the plastic and the metal.
this was just a quick decision to make an example of green roof, very thin on this slope area. If you ask me personally, I would never ever do it again, because I'm convinced that minimum 8 centimeters of substrate needs to be installed due to the wind lift up forces. So this is one thing. Another thing is that biodiversity is not happening on the thinner substrates. Thinner the substrate, smaller the plants, if not even bald green or brown roofs. So minimum 8 centimeters of substrate, and the weight substantial, and yeah, some other layers.
Okay, great. That there were so many questions regarding the time. I think we have to bring the Q&A session to a close-up, but you have you also can use this for connecting each other and also ask questions afterwards. Now I would like to present the upcoming events EFB has, and talk about our recent publications, where you also can find some answers to your questions. So recently we published a solar green roof guidance and benefits of green roofs and buildings. So you can find them on the EFB webpage, and they are free to download. A really important upcoming meeting is the EFB open meeting. By scanning the QR code, you can register for free and be up to date what's going on at the EFB at the moment. And the next open meeting will be on the 12th of February. And on this meeting, we're also presenting the new implementation guideline for European Green Deal's policies. This is a document we were working on in collaboration with Region. And yeah, if you are curious and want to figure out more about it, you can come to the open meeting. Another event which will take part in July is the World Congress of Building Greening 2026 in Berlin. And when you're signing up until the end of January, you get an early bird registration discount. So it will be cheaper until 23rd of January. And if you are interested in submitting a own presentation or participating in the poster presentation, then you have the time to apply for that by 28th of February. So all our webinars are available on YouTube as well. This webinar will be later on uploaded on YouTube, so you can watch them again, and you also can refer them to your friends and colleagues. And then I would like to say thank you for Fürs Grün for sponsoring our webinars and making it free of charge for everyone. So this is from our part. At this point, I will also stop the recording and say thank you for having such a nice webinar with many participants, interesting questions, and a great discussion.